Hey guys, welcome back to Voltage Learning. In today's problem, we have a simple LR circuit, meaning that there's one resistor and one inductor. What we need to find out is if the switch is open and closes at t equals 0, immediately after the switch closes, we should describe the behavior of the circuit. So as usual, we can break this problem down into 3 simple steps. In step 1, we're going to first look at the behavior of the circuit immediately after the switch closes, which means t is equal to 0. In this case, the inductor is going to oppose a sudden change in current, so it initially behaves like an open circuit, a case that happens only when the switch is at t equals 0. When the circuit is an open circuit, that means the initial current through the circuit is going to be 0 amps, and the voltage across that inductor is the full 9 volts of the battery. Next, in step 2, let's look at what happens during the transition between the times of t equals 0 and t equals infinite. The current in the circuit begins to rise exponentially, meaning that the current in the voltage drops over time as the current overall builds up. The behavior of the circuit is modeled by the equation I sub t equals V over R times 1 minus e to the minus t over tau, where tau is equal to L, the inductance, and R, the resistance of the circuit. We can use the circuit to calculate the current at any time that is from 0 to infinity. Finally, in step 3, let's look at what the circuit does when it's in steady state, when t tends towards that infinite value. The current I is going to be calculated using Ohm's law, meaning I equals V over R, which is equal to 9 volts over the 1 kiloohms, because the inductor acts like a short circuit in this case, meaning that the current reaches its maximum steady value at I equals 9 milliamps. And that's pretty much it. If you guys want more circuits tutorials or engineering interview help, visit us at voltagelearning.com and don't forget to like, comment, and subscribe. Until next time, we'll see you guys later.